So it turns out the next thing the instructions want us to solder on is the IC socket here and the Raspberry Pi GPIO header here. And so those are the things we'll do next, probably because it becomes difficult to get to those things once they're in the shadow of these LEDs, which, as we previously saw, are going to stand up off the board quite a distance. So I'm going to put these two on here, and in addition, I'm going to put one of these Max 232s on because I have some Max 232s, what that will allow me to do is run a hardware serial port off of this, which I would like to do because I have a vintage 1981, 1982 Televideo 910 serial terminal that I'm going to want to hook to this thing when I get it all done. So we'll put a socket here, the GPIO header here, the Max 232 here. These capacitors around the Max 232 are required for the correct operation. The value of those capacitors depends on which type of Max 232 you put in this position. But what I'm going to do is place a socket. So for now I'm going to leave these capacitors unpopulated, and then once I find a part to put in here, I have some Max 232s. I need to look up what value of capacitor that particular part requires, and then I'll populate these. But for now I'm going to put this socket in here. I'm going to put this socket in here and the GPIO header on right here. Now when you do this, if you see on the layout, there is a mark here, a little square notch mark at one end of the IC socket footprint. And if you look at the IC socket, there is a little sip cut in the end, or there may be a larger notch cut in the end of the IC socket. And this one, there's a little sip. And those need to line up. That's also where pin 1 of the IC will go. My IC, it's going to be hard to see in this case, but my IC has a it's got a sip cut in the end. See if I can get that out of there. It's got a sip cut in the end right here that will line up with the sip in the socket, which will line up with the mark on the board, and that just ensures that you get everything in the right direction. So we'll take the socket and place it in. This one goes in very easily. Sometimes you have to futz with the legs just a little bit to get them square. In fact, this one goes in easily enough that it's pretty loose. So I'm going to reach around on the back side, and I'm going to bend out the pins on two of the corners to kind of, again, hold it in place while I turn the board over. Once the board is turned over, it's still a little loose there, so I will hold it with my finger. Oops, it fell out even. I will hold it with my finger while I solder the first pin so that I don't lose it, or rather so that it sits flush on the board, because of course we want it to look pretty. Now, that's going to be difficult actually, the way this board is situated, so I will bend a little more carefully on these pins. Again, that can be a bad idea because it can make it hard to get the part out later. But once again, an IC socket is unlikely to fail. So once that's got some tin on it, push into place. I think the pin actually came loose in the socket. Let's take a look at that. It did. The pin raised in the socket. I don't know if that's going to be visible on camera, but this pin raised up in the socket, so I'll push it back down. And touch it with the solder again. Now be careful when pushing around on these metal pins with your fingers. They get hot when the soldering iron touches them, and it's pretty easy to burn your finger. So there we go. That, yeah, that's better. Same thing on this corner. Wet it just a little bit, meld it, push it through. Okay, now I've done the opposite corners. I will check the socket and make sure it's sitting flush. It is sitting flush. Not quite as flush as I'd like. Flush with the board there. And now we'll hit the other, I think 16 pins. I think this is an 18 pin socket. Hit the other 16 pins. With IC sockets, you want to be careful because the socket body plastic often melts at a rather moderate temperature. So if you keep heat on the legs for too long, you'll sometimes loosen the pins in the socket body. That is probably what happened with this guy when it moved just a little bit. So again, put the iron on there long enough to get the pin hot, hit it with the solder, leave it long enough to flow properly, and but then get it back out of there. You know, maybe 1.5 to 2 seconds per pin. And I don't know if it's visible on camera, but of course there's flux around all of these joints, the little smoky looking places here, flux around all these joints on this board. And flux is a corrosive. So when we're all done, we'll take some isopropyl alcohol. I usually keep a bottle right here. This one's about ready for refill. Some isopropyl alcohol, and wipe off the back of this board to wash that flux off of there. Okay, next I will do this Max 232 up here in the corner. And as best I can tell, these neither one of these chips is actually wired to anything but power and ground. The signal wires have headers for both input and output here. I assume to be jumped from the Pi over. I haven't looked closely at the details of that yet. But at any rate, for that reason, I don't think it matters which of these I populate. I may eventually populate both, but that's 4 serial ports if I do both, which I probably won't need. But for now, I'm going to do this guy up here. Again, bend those pins just a little bit to hold it while I flip the board. See if we have a little better luck this time. I'll keep my finger closer. And hit that with some solder. This is a new old stock socket, and I can tell that the pins are not as clean as I would have liked them to be. It's taking a little more heat and a little more flux to get that solder to flow. I guess I should mention what this Max 232 does, and the reason you might want to install one is it converts the 5-volt signals coming from the Raspberry Pi to the plus 12 and minus 12 volt signals that would be used, or up to I think plus and minus 24 volt signals that would be used by an RS-232 port. So this appears to have some standoffs on it. I assume those are to make it stand just a little bit higher off the board. This is the Raspberry Pi header. It's not a directional header, so I assume I can put it on in either direction. We're going to set it right there. Again, this is the only part that's going to solder from the front side of the board. So I'm going to set this in right here. Flip the board over. It's going to fall out. I'll flip the board over, probably reinsert it, and then tack it on the corners and solder. Shove that solder in there. Hold the connector from the back. Hit it just enough to stick that corner. Didn't get enough solder in there. There we go, stuck. Same thing in this corner. It was just enough solder. If you saw what I did there, now ideally what I would do, and I have some helping hands to just push up on the back of this thing. What I did there was laid the solder across this pin a little bit so there was some solder running past it. Held it from the back side, touched it with a soldering iron just to melt it in place. Once it's melted in place, I held the part with my finger, touched up that solder to make that joint a little cleaner. It's still not great. I'll hit it again after I do the others. Right now it's just holding the thing in place. But we just wanted to get a little solder melted onto there to hold the pin. Now with these connectors, I have found it's often best to do from end to end. It's easy to miss a pin that way, but it's less likely to melt the surrounding plastic, which, as I said, often melts at a rather moderate temperature. So instead of doing pins side by side, if we go end to end, we will minimize the amount of heat we add in any one place. Now I did those pretty quick. I'm going to give that a chance to cool. While I do that, I'm going to flip this over and take a look. Make sure things still look good. Sitting tight, sitting square. Probably shouldn't have done quite that many pins. I checked with my finger, but I probably shouldn't have done quite that many pins before I actually looked at it. Because with these large pin count connectors, if you get a number of them soldered down, then you can be in for some hurt when if you have to resolder them. Now, since I did those in that zigzag pattern, I want to check each one and make sure I didn't miss any. And that looks good. Okay. And that is, fairly warm. Probably went a little too fast there at the end. We've got our two sockets. We've got our Raspberry Pi header. It looks like it's in good shape. The next thing we're going to need to do is get started on those LEDs. And as I said a little bit ago, for each one of those, what we're going to do is we're going to pass it through one of these LED spacers, pass the legs through one of these LED spacers, and then get them squared up as best we can. And there's a little legend on the board that indicates that the anode, which is the long pin of each LED, is going to go to the left for all LEDs, it hopefully says. So we take the anode, we thread it into the left hole, the cathode, thread into the right hole, and push the LED down until it sits square on the board. And I'm going to do that, I don't know, 16, like 35, 40 some more times maybe. And we'll see on the flip side. I have to get these pins, when you put it in the spacer, it wants to push the pins so that they come together at the end. You have to get them bent back apart or they don't want to go into the holes. And we want to get these in as square and straight as we can. But there is that alignment plate that will go over top of these once they're all in. So if they're a little bit, wiggly here, that's not a big concern at this point. All right, I'm going to go ahead and put this chip in here before I do these LEDs so that I don't mess them up later. So my pins are a little bit splayed out. They're a little bit out more than 90 degrees. So I just take that, set it on my bench and roll it slightly to try to bend those in just a little bit. Get them closer to 90 degrees. Then seat. There we go. Driver chip is in, 4 more LEDs. We'll put the spacer on and solder these. Have that upside down. Now the instructions say those will come through about 1 millimeter. Mine seem to come through a little farther than that. Let's just seat them all down tight. Now my goal here is going to be to tack one leg of each of these so that I can still reposition them a little if I need to. Before I do that, I'm just going to touch all the legs and make sure that the anodes, the long legs, are all on the same side. In this position, they're on the right. Looks like we're good. We'll do some soldering. The water heater came on beside me not too long ago. Hopefully I can take that rumble out in post. You all won't have to hear it. Let's see how that first row's seated. Pretty well. Just make sure that all my LEDs are still seated tight. So looking good. That alignment plate seems to do a very good job. When you see me dive down behind here, I'm wiping the tip of my iron off on that metal sponge, metallic sponge. When it gets too much burnt flux residue and oxidation and such on the tip, it gets to where it's harder to get the joint hot quickly. And if you spend too much time getting the joint hot, of course you can melt particularly the plastic components on the other end or damage the semiconductors on the other end. So you want to keep your iron clean. With soldering, as with so many other things in life, the key to success is keeping all of your work surfaces and your components as clean as you can. It really looks quite good. So we'll go through and hit the cathode of all those LEDs. Alrighty. That is all the LEDs. Now we go through with the side cutters, with the flush cutters I should say, and trim all the leads. A little too aggressive trimming these over here, and I trimmed part of the solder, which is okay. But I'm sure it weakens the joint, so I'm going to try to be a little more careful. That's one thing, this silver solder that I'm using is pretty soft. I actually don't know if it's harder or softer than regular 6040 or 6337, but it seems soft to me. And it's pretty easy to trim it like that. Okay, again, tons of ugly flux on the back of this board, and we'll clean that up later. I've got a couple of connections I want to look at again. Looking pretty good. Okay. And there's the lamps on the board. Just a few things left to go. we have the rotary encoders over here to mount, and then we have, of course, all of the key switches across the bottom. But I think, if I remember correctly, at this point, we can put a power supply on this and check out our LEDs. So let's see if we can do that.